So good morning, everyone. So for today, we study about the parameter efficiency fine-tuning, which is called PEFT. The idea of PEFT is very simple. When you have a P10 large language model that's quite big, and when you train them with the full fine-tuning is quite using computational and storage quite much. The idea that this one try to solve is like you just freeze everything from the pre-trained model and keep unchanged, but you add some small module inside the model and train this one instead. So it can help the computational, and also it can address the problem about the catastrophic forgetting, which is often when you try to full fine tuning. Okay, and yeah, some paper they said that if you use PET technique, okay, it can sometimes it can outperform the traditional fine tuning as well with the limited data and demonstrate quite superior with the original one. Um, in my section for today, I'm gonna show 5 techniques that PEP existing, which is bit fits, adapter, prompt tuning, prefix tuning, RARA. Okay, so let's go. First, you have to pip install the package with pep and evaluate. Okay, and this is the version that I use for transformer, and this is the version that I use for pep. In this one, I just set seed and check the CUDA that I have. And this is a summarization for me. I have 5 techniques, and you can see that in this one is the original parameter from the GPT-2, but when I used each technique and check, yeah, most of the parameter has been feed, but they add some small parameter that's trainable. So you can see that each of them, it can be big or it can be small. But if we compare the percent that the trainable is quite small already, it's like just only 0.7%, or it's like 0.008%, something like this. Okay. In this 3 function, yeah, the first one just set to check the parameter inside of the model that they have. And the second one just check that the parameter, which one that what was being required get, okay, it's gonna be count as attainable. And yeah, this one just for summarize everything as the top that I showed in the table. So now we go to the bit fit first. Yeah, in the bit fit, the idea is very simple. You just freeze everything in the model, but you keep the bias to trainable instead. You just keep the bias trainable instead. Yeah, you can see when you call the model GPT-2, you just said that if bias is not inside the name, which is come from the model.name parameters, you just make it false. So it means that it's gonna be fits. Yeah, this is the final parameter that they trainable. The second one called adapter. Adapter, the idea is very simple. You just do plug in the small module inside the attention layer. Okay, you can see that in this picture on the left, they just put the adapter module after feed forward. But inside the adapter, just very simple. When you have the vector, you just put another feed forward that make it small, and then you put non-linear layer and change the small layer to back to the original one to matching with the new layer norm. Okay, and yeah, in this case, if you want to try adapter, you can download this package called adapter dash transformer. But for the things that I check for now, this one is quite old, and the version that they have the compatible with the transformer is 4.28.1. Okay, so yeah, so sometimes you don't have to use this one anymore. But yeah, if you want to use this, you just call the transformer.adapter and adapter model. Okay, and you just freeze everything inside the model and add the adapter, but you can set a name as well. Yeah, so then if you see um the architecture inside is gonna have the adapter inside. Okay. So yeah, I'll keep this one. Next one, okay, prompt tuning. The prompt tuning idea is very simple. You just concatenate the embedding in front of the badge. The badge embedding. No, sorry. Actually just add some embedding concatenate inside the embedding. Okay, when you put this one inside the model, it's gonna try to train the concatenate things inside. Okay, so it means that you have something that quite random and you concatenate with the vector that you change from the input sentence. And this random thing is gonna improve itself to learnable and understand what is the context that we train. And if you want to use it, yeah, you just call from PEP and set the prompt tuning config, okay? And you just set first what is the task that you're gonna do, and set the init as a text, okay? This is the prompt tuning init, and you can set how many tokens that you want. So because it's a random thing, but they concatenate with the vector sentence, so you can add the visual token, whatever you want. But the paper that they said they have 5, 10, 20, 50, and hundreds. But yeah, I just put it as an example. Prompt tuning init text is just you can put anything as a description, and yeah, put the tokenization inside, and yeah, you just call the model and put the model inside this function, okay? Get PEP model. So when you put this model inside this function, it's gonna feed everything of the entry the model and adds the small module with the PEP config. Okay, so the next one is very simple idea as a prompt tuning, but the things that separate and not quite same as the adapter or prompt tuning is about PEFT tuning. Try to concatenate the random things, yeah, same as prompt, but they put in front of the K and V, which is they try to learn and improve something inside the multi-layer head instance. Okay, so it means that in this case the module that they learn just only learn inside the attention, only the attention head. Okay, it's not learn everything from the transformer layer. Okay, it's not learn everything, so it means that it's gonna be small, but not same as the prompt tuning. Yeah, and the way that you can set is very simple. You just call PEFT tuning config, okay, and you can set the visual token same as the prompt tuning. Yeah, and put to PEP get model. Yeah, okay, the last one called RORA. The RORA idea is almost same as a PEFT, but the difference thing that they do is they does not concatenate directly with the QKV, but they do as a small module, okay, to let this one learnable separately with QKV and concatenate later. So it means that they still learn inside the attention, but they learn standalone, okay, and concatenate at the end after they pass to QKV already. Yeah, and the things that you can do, you just set the LoRa configs, okay, and set the tags. You can set the R ratio it which between, it means that it means the ratio that they change from the down to up, okay, and you can set the config parameter from the alpha things 32 and dot mass inside here, okay. So the ideas is same as the prompt tuning and PEFT tuning that you can gonna train and put into the get PEP model. Okay, so I also try to show the example how to train LoRa as well. Initially, I just show only the LoRa, but actually you can change anything to be prompt tuning or PEFT tuning. In this one, I just try to use wiki text dataset, and next I try to tokenize the text to be the numeric. Okay, just tokenize. So I remove the text column, so it's keep only the input an attention mark. But the things that I want, because this is a text generation, so it means that each sample is going to continue as, but the things that is it show is like some sample they have 700 tokens, some sample they have 200 tokens. I want to set this thing and modify that every sample should have the same token. So it's like it's a technique that you padding, but you don't put padding. You just add everything until it fit with the box size that you want. So I set that tokenized model max. How much is it? Okay, and I set into the box size, and I just make the function that it have to group every sample and make it keep connect together until same as box size, and then it's gonna go to the new sample. So you can see that this is the original one. So when I do a good text, it can be a small sample. Okay, it can be a smaller sample. And next, yeah, I set the evaluation is about the accuracy just because it's predict the next word. So it means that they just check the label that currently and with the things that predict. Okay. And this case I use the trainer and training argument. Okay. So you just set the output directory that you set. So in this case, I call dbt-rara. So when they train and finish, it's going to create this folder. And yeah, you set learning rate, batch of train and eval, and gradient size that you want, and how many epochs that you use. In this one, I just put only 2 to make it simple. And with add weight decay as well. Okay. So when you have this config, you just put everything from the training arguments inside this trainer function. Okay. You just set the model again. Okay. And set what is the training data set and eval data set. Okay. And add some the tokenization and set the character and put the metric that you use. And then you just call trainer.train. It's going to train the model with the RARA. And yeah, after you finish, you just save the model. But in this case, it's gonna save the RARA instead, not save the entry of the model. Just save the RARA. If you want to save RARA, you just call the model again and save P10. So it means that inside this folder, it's gonna keep adapter config from the RARA and keep the config and everything from the main model as well. And if you want to use inference, you just call PEFT from auto PEFT model for casual LM. Okay. Because if you want to use adapter config this one, you have to use this class instance. And yeah, the idea that you use is very simple. You just call same as the auto model for casual but you just set the directory that you have, which is GPT-2-RARA. And yeah, set the device to the CUDA and set eval to not runnable. And you can see that if I put the prompts like preheat the oven to 350 degrees and press the cooking dough, yeah, and let them generate with the model.gen, and then it's gonna generate 100 tokens. Yeah, and yeah, when they try to generate already, we have to tokenize back because this one is a numerics. Yeah, this is the result. Yeah, that's it. Yeah, you can try to train model easily. You don't have to train and try out the model. Just train able with Aura.